Hi all, very happy evening to each and everyone who is watching this video. This is a special session. I have got a lot of requests, especially from the students who are preparing for civil services. CSAT is an area of concern. CSAT examination, those of you are not aware of it, last year CSAT paper especially was on the difficult side. Most of the students could not clear the cutoff. So I thought I will take a CSAT crash course, CSAT free crash course, CSAT free crash course where I will be taking the most repeated topics in aptitude and reasoning, and I will cover all the models starting from basics to advanced with all the shortcut tricks we are going to discuss. This session will also be useful for students who are preparing for SSC, CGL, those who are going to write D.A.O examination, those who are going to write any other central examination, RRB, NTPC notification also is expected at any point of a time. This session will be in English, not will be in Telugu. This session will be in English because we are addressing audience all over India. So the preferable language that is used is English only. Very important session. I hope the audio it is clear. I hope you are all ready with the notebook and a pen. Write most of the questions. I will try to discuss the traditional method which you know, and also Anil Nair's way of solving, which is simple, easy, fastest and probably the best method to solve. When I say a best method to solve, any method which helps you to attempt more questions with better accuracy and less errors, that is considered to be the best method. So today the topic of discussion will be on reminders. After reminders, what I did is I took a particular topic from where the old questions of CSAT are coming and I collated all the questions. Some questions are from previous year papers, some questions I also included reminders topic from other examinations, and some questions are the most expected questions that might come in number system reminders. After this I will take another topic in number system. Similarly I will get into another topic in arithmetic. Like that, it is going to be a free CSAT crash course, especially for the students who are going to write civil services, but also useful for all the other examination. As most of you know it, I generally do not like anybody wasting my time, and I do not intend to waste anybody's time. So directly I will get into the problem after checking whether right audio and technical issues are perfectly clear. Just to give me a few seconds of time. Very interesting class it is going to be. I hope the audio it is clear. Kindly sit in the class with a notebook and a pen, sir. Entire reminders, whatever questions are there, I will finish it in single session. Right. So reminders. We will do right problem solving, sir. These sessions are through problems. I will explain concepts. Problem solving. But before we solve problems, I will tell you a roadmap. How you should solve reminder related problems. A natural number is divided by another natural number in a fraction, numerator divided by denominator. What is left over? All the problems will be of this model. A numerator is divided by denominator. What will be the remainder? What is remaining? Suppose when I say for example 13 by 5, remainder 13 by 5. The meaning of this line is 13 is the dividend, the number which is getting divided. Whatever that is there in the denominator, that is the divisor. 13 is getting divided by 5. 5 2s are 10. How many times a divisor will divide the dividend? This is quotient. What is left over? That is the remainder. This is called the remainder. Whatever that is left over, that is called the remainder. Whatever that is there in the numerator, that is called the dividend. That is called the dividend. Which number is dividing the dividend? That is called the divisor. Which number is dividing the dividend? That is called the divisor. How many times a divisor is dividing the dividend? That is called quotient. All the problems will be of this format only. What is the format? Dividend will be there in the numerator. Divisor will be there in the denominator. We will not write quotient is hidden in all the questions. How many times 5 is dividing 13? 5 2s are 10, right? That 2 is something which we will hide it. What is left over is called remainder. So 13 is divided by 5, 5 2s are 10, remainder it is 3. 13 is dividend, 5 is divisor, 2 is quotient, 3 is remainder. First point write down, dividend is equivalent to divisor into quotient plus remainder. If you want dividend and divisor, quotient and remainder are given, dividend is given by divisor into quotient plus remainder. Dividend is given by divisor into quotient plus remainder, which we will call it as the division theorem. The most important theorem, while doing remainder problems. Dividend is divisor into quotient plus remainder. Into quotient plus remainder. This table you should know, sir. This table, whenever you are solving remainder related problems, there are two cases that are possible. Denominator, it can be a prime number. Denominator can be a prime number, or denominator can be a composite number. Denominator can be a prime number, or denominator can be a composite number. Denominator, it is a natural number. So natural number is of two types. Denominator can be a prime number, or denominator can be a composite number. Denominator, if it is a prime number, the basic method to solve remainder problems is by using negative remainder. Any problem happens in negative remainder, then I will use Fermat's theorem. Fermat's theorem is a better way to solve remainder problems if a negative remainder is taking little more time. This table you should know. If the denominator is a prime number, we can also use Wilson's theorem. In remainder related problems, denominator can be a prime number, or it can be a composite number. If the denominator it is a prime number, first I will try to solve the question using negative remainder. If I am unable to solve the question in less time, then I will use the concept of Fermat's theorem. If the numerator is in factorial format, Wilson's theorem is used. If the numerator is in factorial format, whatever the way I am telling you, in the same way just listen to the class. 1.5 hours, any question related to reminders, you should be able to solve it very quickly. In between, I will also create a lot of questions. Denominator, if it is a composite number, there are three ways to solve. One is negative remainder. Another is Euler's theorem. If you want to eliminate answer options, we will use Chinese remainder theorem. This Chinese remainder theorem will help us in eliminating wrong answers. It will be used in eliminating incorrect answers. In eliminating incorrect answers. In eliminating incorrect answers. All the problems related to reminders can be solved using these table. Using these table. We will see when this method is effective, when this method is used, when should we look an eye, when should we use a Chinese remainder theorem. Please make a note of that table, and in case if you want to take a screenshot also, you can take it. Extremely important table for a topic to understand in a very scientific way. You should learn it in a structured way. Just randomly solving 20-30 problems, you will be struck, right? Reminder format will be like this. A number will be divided by another number. You are dividing a number by another number. Number which is dividing a number is the divisor. Number which is getting divided is the dividend. How many times a divisor is dividing the dividend? That is quotient. What is left over? That is the remainder. What is left over? That is the remainder. Denominator can be a prime number. Denominator can be a composite number. Only two cases are there. Denominator, it is a natural number. Natural number will be either a prime number or a composite number. If the denominator it is a prime number, first method one is negative remainder. If it is taking little more time, I will get into Fermat's theorem. If the numerator is in factorial format, I will use Wilson's theorem. Similarly, if it is a composite number, I will use a negative remainder. If it is taking more time, I will get into Euler's theorem. If I want to eliminate answer options, it will take Chinese remainder theorem. It will take Chinese remainder theorem. This is the way to solve any problem related to reminders. Any problem related to reminders. Now see. Listen carefully, sir. Listen carefully. What is the question? Find the remainder when 1 factorial plus 2 factorial plus 3 factorial and so on up to 1000 factorial, it is divided by 8. Now, solution. First of all, this question is of factorial format. We should know the definition of factorial. 2 factorial means start from 2, go back towards all the natural numbers till 1. 2, the number before 2 is 1. 2 ones are 2. 2 into 1, 2. If it is 3 factorial, start from 3, go back, right, and do the product of all natural numbers till 1. 3 2s are 6. 6 1s are 6. 4 factorial, it is start from 4, go back to 1. Product of all the natural numbers from 1 to n, it is n factorial. From 1 to n, it is n factorial. Now 5 factorial, from 1 to 5, it is the product. 5, 4, 3, 2, 1. 4 into 3 into 2 into 1, it is 4 factorial. So 5 factorial it is 5 into 4 factorial. 5 into 4 factorial. What is the question, sir? Question is, listen carefully, question is talking about 1 factorial plus 2 factorial plus 3 factorial and so on up to 1000 factorial divided by 8. Divided by 8. 4 factorial it is 4 into 2, 8. 4 factorial, it is divisible by 8. 4 factorial, it is divisible by 8. From 5 factorial, 5 factorial contains 4 factorial. From 4 factorial, all the numbers are divisible by 8. All the numbers are divisible by 8. So, the remaining will be 1 factorial plus 2 factorial 2, 3 factorial 6 divided by 8. 6 plus 2, 8. 8 is divided by 8. What is the remainder? 1. What is the remainder? 1. What is the remainder? 1. Almost all the students who are watching this video, you know this approach to solve this kind of problems. What is the approach? 4 factorial is 4 into 3 into 2 into 1. 4 into 3 into 2 into 1. 4 into 3 into 2 into 1. It is divisible by 8. 5 factorial it is 5 into 4 into 3 into 2 into 1, which again contains 8. From 4 factorial, all the numbers are divisible by 8. So the question, only the first 3 terms are there. If this question is asked to Anil Nair or Anil Nair's students, listen carefully, sir. How I will look at the question and try to eliminate answer options. Anil Nair's way. How I will solve the question. This way you will not find it in any regular textbook, sir. First thing, question is remainder. 2 factorial, it is an even number. 3 factorial, 3 into 2 into 1, even number. From 2 factorial, all are even numbers. Even, it is even. Even plus 1, it is odd. Odd number divided by 8. Odd number divided by 8. Divide an odd number by 8. 1 divided by 8. 1 odd number. 3 divided by 8. 3 odd number. 5 divided by 8. Odd number. 17 divided by 8. 8 twos are 16. Odd number. When an odd number is divided by 8, answer should be an odd number. Answer should be an odd number. Answer should be an odd number. Without even solving it, 50% answers are out. 50% answers are out. That means this method will help us out of 4 options, 25% probability of getting a right answer. Right? You increased the probability to 50% only because of understanding of fundamentals. Answer should be an odd number. Now then you can probably go ahead and see 6 plus 2 is 8. So answer is, it is of the form 8k plus 1. It is of the form 8k plus 1 divided by 8. Why 8k plus 1? All are divisible by 8. 6 plus 2 8. 8 plus 1. 8 plus 1. So answer is 1. I hope the idea it is very much clear. Every mathematics question, there is a better way to solve the question rather than the textbook method. I will show you with examples. I will show you with examples how you can solve a lot of questions. Right? Now see this. Okay, I will use answer option approach. This is not a difficult question, sir. Just you need to, suppose see this question. Remainder 1, 2 power 469 plus 3 power 268, 3 power 268 divided by 22. Divided by 22. It is the question, right? 2 power. By this time you might be checking which power of 2 and which power of 3. Hold on for a few seconds, sir. Right? 2 power 469 plus 3 power 268. What I told you, sir, please see here. If the denominator, it is a composite number. Denominator 22, it is a composite number. Right? I can eliminate incorrect answers using Chinese remainder theorem. By using Chinese remainder theorem, you can eliminate a lot of incorrect answer options. Chinese remainder theorem. 22 can be written as product of 2 coprimes. 2 into 11. Right? If the denominator, it is a composite number. If the denominator, it is a composite number, write this number as a product of coprimes. Write this number as a product of coprimes. Product of coprimes. What is coprime? The numbers HCF should be 1. The numbers HCF should be 1. 22 is 2 into 11. First check it out with 2, then check it out with 11. 2 power anything perfectly divided by 2. 3 when divided by 2, it is an odd number. 3 is an odd number. Odd number divided by 2, remainder 1. Remainder 1. Answer should be, it is an perfectly divisible, 0. Are you all with me? 3 divided by 2, 1. 0 plus 1, 1. That means right answer should be an, which numbers are odd number? Answer should be an odd number. Answer should be an odd number. Are you all with me? Without even doing the reminders, you can eliminate incorrect answer options. Powerful way of solving the question. 22, it is 2 into 11. 2 power 469 perfectly divided by 2. Right? Or you look at like this, sir. Why? This is an even number. This is an even number. You tell me, sir, simple number tree concept. It is an even number. 3 is an odd number. Even plus odd divided by even. Simple format. Even plus odd is odd. Odd number divided by an even number. That too it is 2. Specifically it is 2. Remainder will be 1. Am I right? Remainder will be 1. 2 into something plus 1. That means it is an odd number. Answer should be an odd number. Simple, 2 options are out without even doing reminders. Again I will come back, I will tell you with 11. I am just saying reminders problems can be solved very fast by using answer option. Very fast by using answer option. I will show you some more numbers also. See here. Some more numbers. Suppose, see here. 29 power 29 power 29 divided by 9. I will tell you the basic approach. Again we will solve it. We are just understanding how you can eliminate a lot of answer options by using this. Divided by 9. 29 power, it is 29 power 29, it is an odd number. Divided by 9. 9 is a composite number. It is derived from another number 3. 9 is 3 square. First do it with 3. 3 tens are 30. 3 tens are 30. Negative remainder minus 1. Minus 1 power odd is minus 1. Negative remainder minus 1. If you get a negative remainder, add with that number which is getting divided. 3 minus 1, 2. So answer should be, when divided by 3, it should give a remainder 2. You don't need to do any very lengthy reminders. 29 power 29 power 29 divided by 9. If the denominator it is a composite number, to eliminate incorrect answer options, we will use Chinese remainder theorem. How answer options can be eliminated before itself solving remainder is what we are discussing. 9 is a composite number. It is derived from 3. 3 tens are 30. It is a negative remainder minus 1. Minus 1 power odd. It is minus 1. Negative remainder minus 1. Positive remainder will be 3 minus 1, 2. Or it can be answer when divided by 3. Negative remainder can be minus 1. If the answer is not of this format, then it can never be the answer. Answer when divided by 3, it should give either plus 2 or minus 1. Out. 3 is perfectly divided by 3. It should give remainder plus 2. 4 when divided by 3, 1, but it should give you minus 1. Are you all with me? Beautiful way of solving questions which you will not find it in regular textbook is the beauty of Anil Nair's right mathematics classes. 29 power 29 power 29 divided by 9. 9 is a composite. I used Chinese remainder theorem to eliminate incorrect answer options. 9 is derived from 3. 9 is the child, 3 is the parent. The 9 is derived from 3. Every composite number I will write it as a power of prime factors. 3 tens are 30, minus 1 power odd minus 1, positive remainder 2. Answer should obey the form. When divided by 3, it gives a remainder plus 2. What if more than one answer is there? We are just eliminating answer option. Again I will solve the question. That anyway one more method is there to solve the question. It is like checking whether curry is well prepared or not just by tasting it with a spoon. I hope the idea it is clear. Extremely right. Very. See here, sir. I want students to get habituated like this. 34 is 2 into 17. 2 into 17. 34 it is a composite number. It is odd plus odd, even. Odd plus odd, even. Plus even. Even. Even number, it is divided by 2. Answer perfectly divisible. Answer should be perfectly divisible by 2. Answer should be perfectly divisible by 2. Two options are directly eliminated. Two options are directly eliminated. Sir, other two, yes, I will come back. I am telling you the approach of eliminating incorrect answer option. I will again solve the question. First 5 to 10 seconds, your eyes should be on looking at a question and eliminating two options. There will be 4 to 5 options where you will take calculated risk. Two eliminated, 50% chance is there. Are you all with me? Now, these also tell me, sir. 34, it is 2 into 17. 2. Here it is an even number. One even number into any number. Even is perfectly divisible by 2. Even number, it is perfectly divisible by 2. Answer should be an even number. Where all odd numbers are there? Out. Why you are going and dividing with 34 directly, sir? When there is a smarter way, when Google Map is telling you that there is a congestion ahead, still you want to go in that route? I am telling you that will take a little more time. Keep an eye on the answer option. If you are eliminating 2, then go back and see it whether you can eliminate one more. Now 25, it is a prime number. Let us see if there is anything. All the questions are like this only, sir. Right? Now if you see here, any other questions are there? Now you tell me, sir. 18 is a composite number. This can be written as 2 into 9. Are you all with me? 2 into 9. Yes or no? If the denominator it is a composite number, write it as a product of coprimes. By just now, because you listen to the classes, these are all even numbers. Even plus 1, odd number. Odd number divided by 2. What will be the answer? 1. 7 divided by 2. Remainder, it is an odd number. Are you all with me? Why? Because odd number will be of the format 2k plus 1 divided by 2. Answer should be an odd number. Answer, see here. Answer should be an odd number. Answer should be an odd number. Answer should be an odd number. I hope the idea it is very much clear to you. Without knowing this, if you get into calculation, then few seconds on each and every question, cumulative, the number of attempts will be less. Again I am telling, 2 factorial onwards all are even numbers. Even, it is even. Even plus 1, it is odd. Odd number divided by 18 is a composite number. It is derived from 2 and 9. First I checked with 2. Odd number divided by 2. Answer, it should give 1. Answer when divided by 2, it should give 1. Right? Sorry. Option A is eliminated. Option D is eliminated. These two we are stuck. I eliminated these two. I will come back and solve it later. But I want everybody to understand the importance of Chinese remainder theorem. Chinese remainder theorem. I hope it is clear. Right. Now see here. What is these are all composite numbers. Right. Now you only tell me, sir. 27 power 27. I am only looking at Chinese remainder theorem where the denominator it is a composite number. It is 28. 28 is 4 into 7. 28 is 4 into 7. Yes or no? Check it out. 4 sevens are 28. Minus 1 power odd, minus 1. 4 sevens are 28. Minus 1. Answer when divided by 4, it should give a remainder minus 2. If there is more than one answer option, then I will go to 7. 28 is 4 into 7. 4 sevens are 28. Negative remainder minus 1. Minus 1 power odd number minus 1. 4 sevens are 28 minus 1. It is minus 2. Negative remainder minus 2. Positive remainder plus 2. Answer when divided by 4, it should give remainder minus 2. 4 sevens are 28 minus 1. 4 6 are 24 plus 1. Without even dividing it by next number, just by looking at a question, I got the answer. That is the reason these concepts should be known to you. If it is not known to you and it is not taught to you, then probably these revision classes will help you. 4 sevens are 28, minus 1 power odd minus 4 sevens are 28 minus 1. Answer when divided by 4, negative remainder should be minus 2. Check it out if there is anywhere. Now immediately 7 power 42. The beauty is it takes 5 minutes to understand the concept. You will see the magic happening. Anil sir said that denominator, it is a composite number. I can eliminate wrong answer option. You writing the denominator as a product of coprimes. 3 into 16. First divide by 3. 3 2s are 6. Remainder 1. Answer when divided by 3, it should give remainder 1. Answer when divided by 3, it should give remainder 1. 0 is perfectly divisible by 3. It is divisible by 3. It is 3 into 0 plus 2. Without even doing it by 48, I am able to eliminate 3 incorrect answer options. You know, sir, why most of the students do not clear competitive examination? Lack of knowledge, lack of getting a proper coaching from a good subject matter expert. Most of the students get carried away by what is there in the textbook, and they think that textbook cannot be questioned, and this is the only approach to solve this kind of questions. They end up solving outdated methods. They end up taking another 30 to 45 seconds and waste their time. 7 power 42 divided by 48. If you are stuck in more than one answer option, that right method also will discuss. Probably you will not get any doubts, sir. After one concept is over, I will look at the mobile. If there is any good question, I will discuss the doubt also. Let me complete that concept. 48 is 3 into 16. 3 2s are 6, remainder 1. Answer when divided by 3, remainder should be 1. I hope the idea it is clear. Let me see if there is anything else. Anything else, that is, if the number is divided by 9, if the number is divided by 9, right, this is sum of the first n natural numbers, sum of the first n natural numbers, right. So 9 means sum of the digits should be divisible by 9. Sum of the digits should be divisible by 9. Sir, you said 9 is composite. 9 is derived from 3. So answer should be divisible by 3. Very good. You are thinking in the right direction. So these two options can be eliminated just like that. 9 means 9 out, 8 plus 1 out, 7 plus 2 out, 6 plus 3 out, 4 plus 5. Answer is perfectly divisible. Are you all with me? Looking at a question itself, 9 is derived from 3. So this entire number is divisible by 3. Answer should be divisible by 3. B not possible, C not possible. Two options you eliminated by using Chinese remainder theorem. If you get a denominator composite number, consider yourself lucky. Consider yourself lucky. Tell me, sir, right? 19 power 19. 19 power 19 plus 20 divided by 18. 18 is a composite number. It is derived from 2 into 9. It is derived from 2 into 9. Now see here, this is an even number, this is an odd number. Odd power any number, odd number. Odd plus even is odd. Odd number divided by 2, remainder will be 1. Odd number divided by 2, remainder will be 1. That means odd number divided by 2, answer will be 1. Answer when divided by 2, it should give a remainder 1. And that means it is an odd number. It cannot be, it cannot be. Just plain looking at the question itself, 2 options are eliminated. We are stuck in other 2. Again, when I am discussing a theme, how you can eliminate 2 answer options without getting into problem solving. Again, I will come back to solve each and every question. This is how I will solve the question, sir. When m power 12, right, is divided by m plus 1. It is simple, wherever m is there, substitute minus 1. It is of the question, right, m power 12 minus 1, right, divided by m plus 1. m plus 1, m plus 1. You don't need to do that also. A square minus b square, it is a minus b into a plus b. Very, very important concept. A power n minus b power n is always divisible by a minus b and a plus b if n is even. N is even. If the power is an even number, a power n minus b power n, a power n minus b power n, it is always divisible by a minus b and a plus b. A minus b and a plus b. Suppose for example, 7 power 36 minus 5 power 36 divided by 12. 7 power 36 minus 5 power 36 divided by 12. Power is an even number, so it is divisible by a minus b and a plus b. Numerator is divisible by 12. Answer is 0. Answer is 0. Are you all with me? So m power 12 minus 1 can be written as 1 power 12. A power n minus b power n, it is always divisible by a minus b and a plus b. It is divisible by m minus 1 and m plus 1. M plus 1 only is there in the denominator. So answer for this question is 0. Answer for this question is 0. Very, very important point. Very, very important point. A power n minus b power n is always divisible by a minus b and a plus b when n is an even number. When n is an even number. Sir, what will happen if it is an odd number? I will get to that problem, then I will discuss. A power n minus b power n is always divisible by a minus b and a plus b if n is even. So m power 12 minus 1 can be written as 1 power 12. So it is divisible by m minus 1 and m plus 1. Denominator anyway m plus 1 it is there. Denominator anyway it is m plus 1 is there. I hope the idea it is very much clear. Now are there any other questions? Let us see. Now please write down another note. What we discussed, sir? A power n minus b power n we discussed, and n is an even number we discussed. N is an odd number. Concept. A cube plus b cube, it is a plus b into a square minus ab plus b square. A cube plus b cube is a plus b into a square minus ab plus b square. Very, very important concept. A power n plus b power n is always divisible by a plus b when it is, sir, when n is an odd number. 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 Extremely important concept, sir. Extremely important concept. Right? I hope the idea it is. a power n plus b power n, it is always divisible by a plus b. It is always divisible by a plus b. I hope the idea it is clear. Next one. Now, this is the first concept. Examples. 43 power 101 plus 23 power 101 divided by 66. Tell me the answer. A power n plus b power n. It is always divisible by a plus b if n is odd. That means numerator it is divisible by 43 plus 23, 66. So answer for this question is 0. Answer for this question is 0. A power n plus b power n, it is always divisible by a plus b if n is an odd number. 43 power 101 plus 23 power 101, it is 101, it is an odd number, so it is divisible by a plus b. It is divisible by a plus b. I hope the idea it is very much clear. Suppose if the question is remainder 1, 1 power 5 plus 2 power 5 plus 3 power 5 plus 4 power 5 divided by 5. 1 power 5 plus 2 power 5 plus 3 power 5 plus 4 power 5 divided by 5. First and last, a power n plus b power n, it is always divisible by a plus b if n is odd. First and last is divided by 5. Second and third it is divided by 5. Entire numerator when divided by denominator, answer is 0. 1 power 5 plus 2 power 5 plus 3 power 5 plus 4 power 5. First and last divided by 5. Second and third divided by 5. Entire numerator divided by 5. Now if you see, it is 1 power 5 plus 2 power 5 plus 3 power 5 plus 4 power 5 plus 5 power 5 divided by 5. If 5 terms are there, listen carefully, sir. 1 power 5 plus 2 power 5 plus 3 power 5 plus 4 power 5 plus 5 power 5. Anyway, it is divisible by 5. First and last divisible by 5. Second and third divisible by 5. Yes or no? If I take next 5 terms, 6 power 5, 7 power 5, 8 power 5, 9 power 5, 10 power 5 divided by 5. Next 5 terms, 6 power 5 plus 7 power 5 plus 8 power 5 plus 9 power 5 plus 10 power 5. 10 it is divisible by 5. 6 plus 9, 15, it is divisible by 5. 7 plus 8, 15, it is divisible by 5. It is divisible by 5. Every bunch of 5 consecutive terms, it is divisible by 5. This entire it is divisible by 5. 6 to 10 it is entire divisible. First 5 divisible by 5. Second 5 divisible by 5. Like that till last 5 means 46 power 5, 47 power 5, 48 power 5, 49 power 5, 50 power 5 divided by 5. 50 it is divisible by 5. 46 plus 49, 95 divisible. 47 plus 48, it is also divisible. Every 5 consecutive terms, it is divisible by 5. Like that 50 it is means 10th group of 5. First group of 5, second group of 5, 10th group of 5. Are you all with me? I hope the idea it is clear. Very, very important concept. Very, very important concept. From this one derivative it is there. The derivative we will write. If A1, A2, A3 and so on up to An, if they are in arithmetic progression and the power is an odd number, power it is an odd number, A1 power k plus A2 power k and so on up to An power k is always divisible by Sum of the bases. Very, very important concept. Very, very important concept. Please make a note, sir. If this is base, this is power. If the power is an odd number, a1 power k plus a2 power k and so on up to an power k, it is always divisible by sum of the bases if the power is an odd number. If the power is an odd number, for example, 1 power 13, 3 power 13, 5 power 13, 7 power 13 divided by 16. 1 power 13 plus 3 power 13 plus 5 power 13 plus 7 power 13 divided by 16. Power is an odd number. Yes. 1, 3, 5, 7. They are in arithmetic progression. Yes. Then it is divisible by sum of the bases. 7 plus 5, 12. 12 plus 4, 16. So answer big 0. Answer big 0. 1 power 13 plus 3 power 13 plus 5 power 13. The bases should be in arithmetic progression. Two conditions it should satisfy. The base should be in right arithmetic progression. Power should be in odd number. Then it is divisible by sum of the bases. Sir, how you got it? Simple, sir. A power n plus b power n. It is divisible by 8. 3 power 13 plus 5 power 13. Power is an odd number. 3 and a power n plus b power n. It is divisible by 8. Numerator, it is divisible by 8. Odd plus odd, even. Odd plus odd, even. Numerator, it is also divisible by 2. Any number divisible by 8 and 2 is divisible by 16. 8 and 2 is divisible by 16. I hope the idea it is clear. Think logically. a1 power k plus an power k. It is divisible by a1 plus an. a2 plus an minus 1. Like that you will get the sum of the bases. Why behind the concept is also very, very important. If the power is an odd number and the bases are in arithmetic progression, then it is always divisible by the sum of the bases. Sum of the bases. Any question is there related to it? Let us solve. Any question is there? There are a lot of very good methods are there to solve. The problem is not knowing that method. See here. You tell me, sir. Just now I discussed 24 power 3 plus 25 power 3 plus 26 power 3 plus 27 power 3 divided by 102. Immediately you know the logic. It will strike you. Sir said that power should be an odd number. Power is an odd number. 24, 25, 26, 27. They are in arithmetic progression. Yes. That means in numerator it is divisible by 24 plus 25 plus 26 plus 27. It is 51. This is also 51. 102. 102. Are you all with me? 102. 102 divided by 102. Answer is big 0. Answer is big 0. These also you can use Chinese remainder theorem. 102 is 2 into 51. This is even. This is odd. 26 is even. 27 is odd. Odd plus odd even. Even plus even even. Even number is perfectly divisible by 2. Answer should be an even number. All are even numbers are there. So, except 1. Except 1. I hope it is the idea, it is very much clear. In fact, see here. Once you know the concepts, without even, if you forgot this method, how I will solve it? 51 is 3 into 17. You are stuck with 2. Go to 3. 27 is divisible by 3. 24 is divisible by 3. 3 8s are 24. Remainder 1. 3 8s are 24. Right? 2. 2 cube is 8. Or 20 a power n plus b power n. It is divisible by a plus b because the power is odd. That means these two are divisible by 51, which is divisible by 3. That means answer is perfectly divisible by 3. Answer is perfectly good way of putting the answer. Two options he kept. Are you all with me? If you are stuck here, go to 17. You are stuck here, go to 17. A power n plus b power n is divisible by a plus b if n is odd. A1, A2, A3 till An, if they are in arithmetic progression and the power is an odd number, it is always divisible by sum of its bases. It is always divisible by sum of its bases. Now see here, sir, right. Listen carefully. We will just use answer options. 55 power 3 plus 17 power 3 minus 72 power 3. Right, let us take a little one of the answer option. N is divisible by both 3 and 17. N is divisible by both 3 and 17. Check it out for 3. Okay, you don't need to do that also. A power n plus b power n, it is always divisible by a plus b. That means it is divisible by 72. It is divisible by 72. Answer should be divisible by 72. Which answer option will divide 72? 3. Finish. Are you all with me? Right? 55 power 3 plus 17 power 3. A power n plus b power n is always divisible by a plus b if the power is an odd number. Power is 3 odd number. So these both it is divisible by 72. These also is divisible by 72. That means answer should be divisible by 72. Which answer option is dividing 72? Or next way of looking at it, right? 55 power 3 minus 72 power 3 plus 17 power 3. This can be written as 55 power 3 plus minus 72 power 3 plus 17 power 3. A power n plus b power n, it is always divisible by a plus b if n is odd. That means it is divisible by 17. This is also divisible by 17. Answer should be divisible by 17. These approaches you will not find it in any regular textbook. I hope the idea it is clear. A power n plus b power n. In these I applied to first two, then I applied to first and last. Minus 72 I wrote it as minus 72 power 3. A power n plus b power n. It is always divisible by a plus b. It is always divisible by a plus b. This is how you should solve remainder problems rather than going in a step-by-step approach. Let me see if you have any doubts in whatever I discussed. Just 1 minute, let me see your doubts. In case if you got any doubts, please ask me, sir. I am looking at the comment box. Any academic doubt, valid doubt, relevant doubt, I will be more than happy to answer it in the live class. Kindly reply yes if you have understood everything, or in case if you got a doubt, mention your doubt. 1 or 2 minutes I will be looking at the comments. I hope everything it is clear. All clear? Right. Right. Idea clear, right, sir? Right. Next, let us get into some more. I will not waste any single time of yours. I think if you are spending 1 to 1.5 hours with me, at the end of the day, at the end of the class, you should have a feeling that I have learnt a lot in this session. Now see, 1 factorial plus 2 factorial, already we did this kind of model. 1 factorial plus 2 factorial. Denominator, it is a prime number. Denominator composite number. How to eliminate incorrect answer options we have seen. Now we will look at the questions where the denominator, it is a prime number. Denominator, it is a prime number. The problem with prime number is it is an orphan, sir. Suppose if I take 12, this 12 has 2 children, 2 and 6. 12 has 2 children, 3 and 4, right? 12 can be written as same number into, it is, right, self-love kinda category, right? A prime number is a classical example of a self-love. The number can be written by the number and 1 itself. Self-love category, but these an orphan. Prime number is an orphan. If it is a composite number, I would have written it. 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. 5 factorial onwards, all are divisible. So all can be eliminated. All can be eliminated. 1 factorial, it is 1. 2 factorial, it is 2. 3 factorial 6, 4 factorial 24. It is eliminated. 3 divided by 5, answer will be 3. 3 divided by 5, answer will be 3. 1 factorial plus 2 factorial plus 3 factorial plus 4. After 4, all the numbers are divisible by 5. So 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. 4 factorial 24, 3 factorial 6, 2 factorial 2 and it is 1. These are divisible by 5. Answer is 3. Answer is 3. Let me come from the beginning. I hope first question it is very clear. Now reminder 1, 51 power 203 divided by 7. 51 power 203 divided by 7. How to solve this kind of questions? Now see here. Negative remainder approach. First thing, either negative remainder or positive remainder. Both the approaches will give you the same answer. 7 sevens are 49. Leftover is 2. 2 power 203 divided by 7. 2 power 203 divided by 7. Always make, whenever the remainder problems are like this, numerator power x divided by denominator, remainder, try to make numerator less than denominator. This is the first important step while solving remainder problems. Numerator power x divided by denominator, make numerator smaller than denominator. Make numerator smaller than denominator. 7 sevens are 49. Remainder it is 2. Now second step is, which power of 2 when divided by 7 I will get plus 1 or minus 1. 2 square it is 4. 2 cube it is 8. 8 divided by 7 1. 3 6 are 98. 23. 3 67s are 201 into 2 square divided by 7. 8 when divided by 7 1. 4 divided by 7 4. 4 divided by 7 4. Listen carefully, sir. 2 power 2. Why these 2 came? 7 sevens are 49. Leftover it is 2. 2 power 203 divided by 7. Which power of 2 when divided by 7 I will get plus 1 or minus 1. 2 cube 367s are 201 into 2 square. 8 divided by 7. Remainder 1. 1 4s are 4. Answer for this question is 4. Answer for this question is 4. Answer for this question is 4. Are you all with me? I hope the idea it is clear. This is one method. Another method is remainder 1, a power p minus 1 divided by p, it is 1 if p is a prime number. This we call it as a Fermat's theorem. This we call it as a Fermat's theorem. A power p minus 1 when divided by p, remainder it is 1, right? This is when the denominator it is a prime number. So according to the and A and P should be co-prime. A and P should be co-prime. 51 power 6 divided by 7, it is 1. 6 3s are 18, 23. 6 3s are, that means 51 power any multiple of 6, it is also 1. We are left with 51 power 5. Then natural process. 7 7s are 49. 2 power 5, 32. 7 4s are 28 to 4. Answer 4. By using positive or negative remainder, you are getting the answer fast. I hope the idea it is clear. Denominator prime number. Either you can use positive or negative remainder, or you can use Fermat's theorem. For certain problems, Fermat's theorem will help us to solve the answer very, very easily. Now see here, sir. Let us see. I think this question you can solve it, right, sir? Find the remainder. Already we discussed this model. 16 power 3 plus 17 power 3, 18 power 3 plus 19 power 3 divided by 70. 16, 17, 18, 19, they are in arithmetic progression. Power is an odd number. That means it is divided by sum of the bases. 16 plus 19, 35 plus 35, 70. Numerator it is divided by 70. So answer should be 0. I hope the idea it is very much clear. Sir, can I solve it like this? Sir, you said denominator it is a composite number. I will write it as 7 into 10. A power n plus b power n. It is divisible by a plus b. That means first and last term divided by 35. That means it is divisible by 7. 17 power 3 plus 18 power 3. It is also divisible by 7. Answer should be divisible by 7. That is an alternative approach. 70 it is a composite number. So I am writing it as a product of coprimes. 70 as 7 into 10. First and last divisible by 7. Second and third divisible by 7. That means numerator it is divisible by 7. Denominator also 70 contains 7. That means answer should be divisible by 7. Let me solve when the denominator is a prime number first. Right. Now listen carefully, sir. Please tell me the answer. 6 is 2 into 3. Denominator composite number. So I am writing it as a product of coprimes. 6 can be written as 2 into 3. All these are even number, and so on up to even. Even, it is even. Even divided by 2. That means answer should be an even number. Are you all with me? Right. Now see here. 3. Now if you see 10 power 1 plus 10 power 2 plus 10 power 3 plus 10 power 4 plus 10 power 5 and process continues till 10 power 100. If I divide by 3 3s are 9, remainder 1. First 3 are divisible by 3. Yes or no? 10 divided by 3. 3s are 9, remainder 1. 3s are 9, remainder 1. 3s are 9, remainder 1. It is perfectly divisible. 3s are 9, 1. 3s are 9, 1. 1 plus 1, 2. First 5 groups I got 2. Like that 20 groups are there. 2 20s are 40. 40 divided by 3, remainder 1. Answer when divided by 3, it should give remainder 1. Please don't get into any heavy calculation. 10 power 1 divide plus 10 power 2 and so on up to 10 power 100 divided by 6. 6 can be written as 2 into 3. All are even numbers. Even number perfectly divisible by 2. Even number perfectly divisible by 2. Answer should be perfectly divisible by 2. See, seems like a long calculation. Sometimes knowing the method, you eliminated 3 incorrect answer options. Sir, I want to do it with 3. 3. Take 5, 5, 5 units like the 20 groups. 3 3s are 9. 1, 1, 1, 1, 1. 5 ones. 5 divided by 3. Remainder 2. Every 5 groups, I got remainder 2. Like the 20 groups are there. 2 20s are 40. 40 divided by 3. Remainder 1. 40 divided by 3. Remainder 1. 40 divided by 3. Remainder 1. Understood the idea? I hope the idea it is clear. This is what you should do it during your examination time, sir. Now, you only tell me, sir. Please tell me. Anil sir said one approach. Let me use that approach. 7 power 7. 7 power 2 sevens. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 7 power. How many are there? 3, 3, 3. 9 sevens are there. 3, 3, 1 more. 9 sevens. 9 sevens are there. It is from starting from 1 7 till 9 sevens. Total 9 numbers are there. Total 9 numbers are there. First number starting with a single power of 7. Next also it is 2 sevens. Like that 9 sevens are there. 9 numbers are there. 9 numbers. It is divided by 6. 2 into 3. 2 we will do. 9 numbers are there. First is an odd number. Second is an odd number. Like that total 9 numbers are there which are odd. Odd, 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 9 odd numbers. It is answer is an odd number. 9. Odd number of odd numbers. First odd plus odd even. Next odd plus odd even. Third odd plus odd even. Fourth odd plus odd even. One more odd will be there. Answer is an odd number. Odd number divided by 2. Remainder 1. Answer when divided by 2. It should give a remainder 1. Answer when divided by 2. It should give a remainder 1. Are you all with me? So, first out, last out. 3. 3 2s are 6, 1. 3 2s are 6, 1. Like that 9 ones are there. 9 ones added 9. 9 is perfectly divided by 3. Answer when divided by 3. Remainder 0. Answer when divided by 3. Remainder 0. I hope the idea it is very much clear. It is divided by 6. 6 is 2 into 3. 9 odd numbers are there. If I add 9 odd numbers, I will get an odd number. Odd number divided by 2, remainder 1. Answer should be an odd number. First out, last out. It is divided by 3. 3 2s are 6, 1. Like that 1 1 1 1. 9 odd numbers are there. 9 1s are 9. 9 divided by 3. Remainder 0. 9 divided by 3. Remainder 0. Answer should be perfectly divisible by 3. Answer when divided by 2. It should give a remainder 1. It should give a remainder 1. I hope the idea it is very much clear. Another, it is a very good question, sir. 23 power 10 minus 1024 divided by 7. 23 power 10 minus 1024 divided by 7. Now see here, sir. Some examples. 1024 divided by 7. First example. Second example. 102, 103 divided by 7. Third example. 137, 137 divided by 7. Now see here. The divisibility rule of 7 is, start from right hand side, take a group of 3 digits, alternatively plus minus. Start from right hand side, take a group of 3 digits, alternatively plus minus. Start from right hand side, take a group of 3 digits, alternatively plus minus. Take a group of, start from the right hand side, take a group of 3 digits, alternatively plus minus. 24 minus 1, 23. 23 divided by 7. 7 3s are 21. It is 2. If the number of digits are more, the process will become little easy. 103 minus 102. It is 1. 137 minus 137, 0. 137 minus 137, 0. Please write down this point. Any 3-digit number written even number of times, any 3-digit number written even number of times, is always divisible by 7, 11, 13. 7 into 11, 77. 11 into 13, 143. 7 into 11 into 13, 1001. Please put a star mark. Please put a star mark. I hope the idea it is very much clear. What is the divisibility rule of 7 or 11 or 13 or the combination of any two or the combination of all the three? Start from rightmost. Take a group of 3 digits, alternatively plus minus. 24 minus 1, 23. 7 3s are 21, 2. 103 minus 102, 1. 137 minus 137, 0. Right? So this will help us in solving some numbers with bigger digits. 7 3s are 21. It is 2. It is 2 power 10 minus. It is, how much it is? 2. 2 power 10 minus 2 divided by 7. Divided by 7. I hope the idea it is clear. Right. 2 power 10 minus 2 divided by 7. Now if you see, this can be written as 2 common 2 power 9 minus 1 divided by 7. Don't calculate. 2 common 2 power 9 minus 1. These 2 power 9 minus 1 can be written as 2 cube whole cube minus 1 cube. Yes or no? A power n minus b power n. It is divisible by a minus b. So answer is perfectly 0. Answer is perfectly 0. Again I am repeating. 7 3s are 21. It is leftover, it is 2. 2 power 10 minus 1024. Take a group of 3 digits, alternatively plus minus. 24 minus 1, 23 divided by 7 is 2. 2 power 10 minus 2. 2 common 2 power 9 minus 1. 2 power 9 minus 1 can be written as 2 cube whole cube minus 1 cube. A cube minus b cube is a minus b. So answer is perfectly divisible. Answer is perfectly divisible. I hope the idea it is clear. We will try to cover as many models as possible. Now see here. This question we will do it. It's a very good question. In fact, it's a CAT exam original question. Question is 2 2 2 2 2 2 2 power 5 5 5 5 5 plus 5 5 5 5 5 power 2 2 2 2 2 divided by 7. Divided by 7. Take a group of 3 digits, alternatively plus minus. Take a group of 3 digits, alternatively plus minus. 222 minus 2, 220. 220 power 55555 plus 555 minus 5, 550 power 22222 divided by 7. I decreased the number of digits. 222 minus 2, 222. Divisibility rule of 7 is, start from right hand side, take a group of 3 digits, alternatively plus minus. 222 minus 2, 220. 7 3s are 21, 10, 7 1s are 7, 3. 3 power 5555. 7 7s are 49, 60, 7 8s are 56, 4. 4 power 22222 divided by 7. Over answer. This can be written as 3 power 5 power 11111 plus 4 square power 11111 divided by 7. A power n plus b power n. It is always divisible by a plus b if n is odd. So it is divisible by 3 power 5 plus 4 square. 243 plus 16 is 259. It is divisible by 7. Answer is 0. Answer is 0. I hope the idea it is right. Very much clear. Please put a star mark on this question. First 4 digits became 3 digits. 3 digits became single digit. Here what I did, 3 power 4 5s plus 4 power 2 2 2s divided by 7. So I wrote it as 3 power 5 power 1111 plus 4 square power 1111. A power n plus b power n is always divisible by a plus b if n is odd. 243 plus 16 is 259. 259 is divisible by 7. 259 it is divisible by 7. I hope the idea it is clear. It is an original CAT previous year question. Last year CSAT, a good number of CSAT question are similar to some old CAT papers. So I have included one such question, right? I hope we have solved some problems based upon this, right? What we will do is, we will continue this session. You have your dinner and we will be back again at 9 o'clock with session number 2 of reminders. Thanks a lot. With love, Anil Nair.